right, hello. So here we are, lesson 8B. Today we're going to be writing the equations that go with these lines. So it's really not any different. Remember, the form of equation is y equals mx plus b, where m is the slope, change in y over change in x, and b is the y-intercept, the 0 point. Whatever goes with 0 on the graph. So the best way to do this is to make a little table. So we're going to make a little xy table. And we're going to look at the first point. So the first point is 0, 10 on here, 0, 10. So that means our initial value right here is 10. Then we're going to look for where it changes from there. So find another good point, and it looks like there's one right there. So this next good point is at 2, 8. Be careful because sometimes they change up the increments that they go by here. So this one went by 2s on both and not 1. So it's just best if you look for the ordered pairs and then you don't have to worry about it. All right, so change in y over change in x, 10 goes down to 8. So that went down 2 as x added 2. And so our change in y over change in x is going to be negative 2 over 2, which reduces down to negative 1. So our rate of change here is negative 1 y per x, whatever these are standing for. So to make an equation, we would literally just write y equals negative 1 x, because remember m goes next to our x. That's our coefficient. Our coefficient is changing by decreasing by 1 every time after it started at 10. And so we could write our equation like that, or we could write y equals 10 minus 1x, or we don't even need the 1 in front. We could write y equals negative x plus 10. Plus 10. All right, so there we are. So it's how it changes and where it starts. Let's try again. What about this one? This one starts, if you can see it, let me zoom in a little bit. Oh, that's better. All right, this one starts here at 50. So the initial value is 50, or 0, 50. So I'm going to make my table x and y. It starts at 0, 50, and then the next good point's right here at 10, 200. 10, 200. So see what I mean by the increments? Sometimes it goes by weird amounts. All right, so we find our change in y and our change in x. 50 goes up to 200 by adding 150. So my change in y is 150, and my change in x is 10, and so I write 10 down there. And 150 divided by 10 is just going to be positive 15. And so that's my rate of change, which tells me my equation is going to be 15x, and then the initial value, which was 50. Okay, so don't forget, it's y equals mx plus b. All right, let's try again. On this one starts at 25. My initial value is 25. Remember, it's y equals mx plus b, so if you have to write it again, you can. Let's make our table of values. So our table of values, 0 goes up to 25. The next good point looks like it's right here, and that's at 1575. 1575. Change in y is they added 50. Change in x is they added 15. So my change in y over change in x would be 50 over 15. I can reduce those by 5s at least. I can see that. And so that would be written as 10 over 3. So if my rate of change is 10 over 3, $10 for every 3 months in this case, then my function, my equation would be y equals 10 over 3x, because it's changing every time, but it started at 25. So whatever's across from the 0 is where it started. So that's the equation. Last one in this one, that's why I'm combining it with lesson 9. Let's write our table of values. All right, this one starts at 0, 300, and then my next good point looks like it's right there at 30, 100. So 30, 100, 30, 100. Change in y is it went up, it added 70. Change in x is it, it went from 0, 300. Oops. See, mistakes can happen. Let's change that. That's 0, 300. I wrote 0, 30. 0, 300 to 30, 100. This went down 200. And I noticed that mistake because I was saying it went up when I see this line is going down. So that gave me the hint, oops, I might have done something wrong. So this line is going down. It should be a negative slope. Remember slope, dude? Nice, negative. So it's going down 200, and the x added 30. So my change in y over change in x would be negative 200 over 30. So I know I can reduce that by tens to write negative 20 over 3. And we'll just keep it at that. So that means my rate of change is negative 20 over 3. My initial value is across from the 0. So that means it's 300. And so my equation is y equals negative 20 over 3x plus 300, because that's where it started. So this one starts at 300 and then goes down 20 every 3 months. Goes down 20 every 3 months. So that's what that means. Let's look at lesson 9, because lesson 9 goes ahead and gives it to us in tables. And this one is where I really wanted you to see this. So this one does not give us the initial value. So what do? So let's try this. We know these, and so we can figure out how it's changing. So from 65 to 78, it added 13. From 12 to 16, it added 4. So we can see how the change is occurring. We can see this rate of change. So it's adding, the change in y is 13, the change in x is 4. So every time it's adding 13 on the y and adding 4 on the x. So that means my rate of change is 13 over 4. So I know my equation starts y equals 13 fourths x. I just have to figure out where it started. So that might take a little while. On this one, I'm going to show you how to work backwards. So if we know it was adding 4, what if we go backwards? We know that if we subtract 4, this would have been 8. And if we take away 13, this would have been 52. And I think we could keep working backwards. So that's one way you can do this. So take away 4, take away 4. So that means I've got 2 more steps to get to the 0 value. 52 minus 13, let's see, 52 minus 13, that's going to be what, 39? And 39 minus 13 again is going to be 26. So that tells me my initial value must have been 26. So one way to do this is to work backwards. So you could, one method, let's write it down here. There it is, sorry. One method is work backwards. So work backwards to x equaling 0, and that will tell you your initial value. So as long as you get down to the 0, that'll tell you your initial value. That's not always going to work, so let's see a case where that doesn't work. Let's look at this one. All right, so this one, let's see if it's changing by nice numbers. Let's see, 13 over 10. Let's see, this one's going to be 19 over 8. Ooh, these are ugly. So let's go ahead and work on one that's going to be a nice one for you. So cross this out. Ugh, those are going to be ugly numbers. Let's try a nicer one. Rewrite this in instead. Let's try 1, 7, 2, 9, 3, would be 11. There we go. All right, so let's work on this one, because here's what you'll really notice. If you do not have the initial value, but you can figure out the rate of change, we can use that in slope-intercept form to figure out the starting point. So here, from 7 to 9, it's changing by adding 2. From 1 to 2, it's changing by adding 1. And so that tells me my slope is 2. 2 over 1, which is 2. So I could start writing this out, y equals 2x, but they had to have done something else. So think about that. 2 times 1 should have given me 2, but it didn't. It gave me 7. 2 times 2 should have given me 4, but it didn't. It gave me 9. And so I can plug in numbers and figure out what the extra must have been. So they added something else. So let's figure that out. Let's use that first point, 1, 7. And if I plug in 7 for the y, we know that the slope is 2 times the x, which is 1, plus the b. Whatever that b is, we can figure this out. 7 equals 2 plus b. So if I take away 2 from both sides, I end up with 5 equaling b. And so that tells me my initial value must have been 5. So the equation for this is y equals 2x plus 5. So we could either get there by working backwards, or we can get there by plugging stuff in. So right here we plug in an x, y, and m to find the b. So to find the initial value, we can plug in one of the x's with its y for x and for y, and figure out the m to figure out the missing part, the b. All right, so that's going to be all for today. Go ahead and try this in the exit ticket. And remember, we'll be reviewing tomorrow. Come see me at the back conference table if you need some help. Bye-bye for now.